Hey, 8th graders, continuing our look at systems of equations. Tonight we're looking at lesson 26, characterization of parallel lines, and 27, nature of solutions of a system of linear equations. So here we have our system. That's asking us to graph it. So there it is. Y equals 2/3 x plus 4, and y equals 4/6 x minus 3. So what do you notice about the slope? Well, if you simplify 4/6, it's going to be 2/3. So they're the same. Okay, what about the y-intercepts? Are those the same? No, they're different. Okay, so what do you notice about the lines? Well, if you didn't notice already because of the title of the lesson, they're parallel lines. So now our next question is, how can you tell if a system of equations has a solution or not? So if the slopes of the equations are different, the lines will intersect at some point and there will be a solution. If the slopes of the equations are the same and the y-intercept points are different, then the equations will graph as parallel lines, which means the system will not have a solution. Okay, so will the system have a solution or not? First, let's rework those. Oops, sorry guys. Okay, so we're going to write them in slope-intercept form so we can see what they look like. So here we're going to subtract 4x. Here, subtract 6x. So this one is 2y equals negative 6x plus 5. Divide everything by 2. Y equals negative 3x plus 5 halves. Here, negative 3y equals negative 4x plus 5. Divide by negative 3. Y equals 4/3 x plus, minus 5/3. So, will the system have a solution? Yes, for the first equation. This is the first system. Now let's look at the seconds. Okay. So here we go again. This one. Did I write that right? This should be a y. So we're going to just minus 1, minus 1. So 4y equals x minus 1 divided by 4. Y equals 1/4 x minus 1/4. Here we are going to add 2x. So we get 8y equals 2x plus 14 divided by 8 is negative 1/4 x minus 14 over 8. Just try to double check here on if that should be a negative somewhere else. 1 second here. Oh, this is supposed to be positive. I included a negative. That's why. Sorry. So they have the same slope. Therefore, they will be parallel lines, so that system does not have a solution. Okay? So next, how do we know what type of solution? So a system of linear equations can have a unique solution, no solution, or infinitely many solutions. Systems with a unique solution are two linear equations with different slopes that intersect at only one point. Systems with no solutions are two linear equations with the same slope, different y-intercept points, and they'll be parallel lines. And then systems with, that should be infinitely many solutions, sorry. are two linear equations with the same slope and same y-intercept point, so they'll be the same line. So let's determine, or first we're going to solve this, sorry. So we'll solve it by substitution. So that's the other thing we can do. So if they're the same equation, like they equal the same thing, then we can write them as equals to each other. So then we can solve for part of the equation. So here we have it. We're going to subtract 5x and subtract 3. We get negative 11 equals 1x divided by 1. Negative 11 equals x. Okay, so you can plug it back in and figure that out. So let's do one more. Okay. We're going to subtract 3y, subtract 2. So we have 1y equals 13. Again, we divide by 1 just for curiosity's sake. Y equals 13. Okay. So then you could plug it back in again to solve the equation. So you're going to complete the modal questions for lessons 26 and 27. A part of your assignment is going to be determining whether or not it's your whole assignment, sorry, whether or not the system has no solution, one solution, or infinitely many. So remember this here, unique solution, so one solution, they have different slopes and intersect at one point. No solution is they have the same slope but different y-intercepts. Infinitely many, same slope, same y-intercept point. You'll notice on the post with this video, there's a second video to watch if you want some extra help, and there's also an IXL skill linked if you want some extra practice. Please let me know if you have any questions and have a great day.